Hello everyone, my name is Tim and I am building PACT for the OG hackathon. PACT is the settlement layer for verifiable AI as a service. Every inference produces a tier-attested ECDSA signature recoverable on-chain. Sellers mint AgentNFTs and buyers pay per call. Reputation also travels along with the token. Alright. Already into the marketplace. This is service 1, a solidity audit agent. We can see the model and the details for this agent. Alright. This model charges 0.001 OG per compute, and we are going to hire this agent now to do an audit for us. Alright. Okay. So our wallet is currently connected, so we can use this agent to make an audit. Alright, so I pasted the prompt to audit this contract for re-entrance vulnerabilities, and I'm going to submit this job to the agent. Alright, the transaction signs create job on the PactEscrow. The amount is logged on the escrow, and the commitment hash of our prompt is anchored on chain. We're going to wait a couple of seconds for the confirmation, and it's going to direct to the job page where we're going to see the state flow for the whole loop actually. Alright. In the background, the seller agent, which is currently running here, you can see the agent has caught a new job that is active. So the seller agent is going to pull every loop, and until it sees a new job, it calls it into the 0G compute and gets back the inference. Then it fetches the T attested signature and returns the output back to us. But we won't be seeing this output here visibly on the UI. Right, we are going to get the output right here on the terminal. So it's going to take a couple of seconds for the whole verification flow. I think about 45 seconds. The contract emits the hash of this bytes on chain. That hash is what the T signed, and that's what the attestation verifier checked. The delivery of the actual byte is the seller's channel, not the protocol by design. The next version we'll be shipping would go over the 0G storage with ECIES. So the bytes are encrypted to the buyer's wallet. Same cryptographic guarantees, and it will work end-to-end on the 0G primitives. Right, we can see we already have the output for this verification that we ran from the agent. So you can see this function is not very vulnerable to reentrancy because it performs no external calls to untrusted contracts. So the audit we ran earlier, we can now say, okay, it has that particular smart contract doesn't have a reentrancy bug on it. I'm going to head back into jobs and come into this part here, so we can view and verify the output, which is our mode. The T signs a 5-field canonical text. We have the content hash, the usage hash, the provider type, the provider identity, the TLS certification fingerprint. We wrap it in EIP 191 and hash with KECA 256. We recover the sign-in address from the signature using ECDSA SEC 256 K1 in our browser. So right now the address we are going to recover is going to match with the address from the PactRegistry. The first service registered signer, so the signer that registered the first service, right? So we are going to see here, we can see the signature, we can see the graph, we can see the registered signer, which is also here for service 1, is matching with the address from here. So this is a match, and the AttestationVerifier proves that there's no fraud case. So like the surface area is proving that the data is right. Alright, I'm going to scroll into marketplace now and view the reputation score for this agent. Alright, let's see. Okay, we have the reputation score for this agent. It has done a total of 3 transactions, and the reputation score updates itself. It's not a star rating, it's anchored to the seller's ERC-7857 INFT, which is a transferable token. So the agent does the work, it earns the reputation, and not the wallet earning the reputation for it. Alright, now I can configure TriPact via the MCP. We also have the indexer, and you can get more details on the documentation page, but we have the indexer and we have the MCP. So I would configure to make some calls from TriPact from the MCP. The MCP is actually configured to my Cloud desktop, so the settings configuration is on the README for anyone to check. Alright, so let's use the previous prompt to like query the data from TriPact. Right, we currently still have just one service on TriPact, so we can just say, okay, let's verify job 3, verify job, okay, last job run or job 4, verify job 4, and tell me if the output is true and no fraud case. So it's going to pass the data into the server, and I'm going to get the details. It's going to process the details from job 4, which was the last job we ran, so we can know if the detail was wrong, or probably there's a fraud case, or the AttestationVerifier cannot verify that that job output is right or wrong. Alright, we can see the output now. It says the attestation is authentic, but it doesn't actually claim that the output is true because it can't see our output, but we can see the output back on the terminal where the seller watchbot shows it to us. Right, and you can also read other details, no fraud level, the signature is clean, and that's pretty much part of the tools you can call from the MCP server. Alright, we also shipped the SDK here, which you can integrate in just 25 lines of code if they want to go through the indexer, which we have the indexer just right here also. Right, so we ship the SDK for developers to build on TriPact if you want to skip the indexer, and you can use this to configure tier attestations for agents and the likes. Alright, so simply TriPact says just trust the math, because the T runs on some mathematical processes, and the contracts are actually live on Mainnet, and all the 56 tests passing with the published SDK, the hosted MCP server, and the public indexer. Thank you, everyone.